Okay, it seems to be 2 o'clock right now, and we have still some participants coming in. But anyhow, welcome to this seminar. And we are about to start. So we are going to record the seminar, and it will be available at CSC web pages after this presentation, including the questions part at the end of the presentation. And for questions and comments, you can use the chat box, which you can find from your Zoom application. It might be hidden, but when you click more on the menu, you should see the link for chat, and you can use that for questions. I will address them at least at the end of the presentation, maybe during if they are related to what I'm talking at the moment. And as mentioned, we will record this and it will be available on YouTube and of course linked to CSC web pages as well. Also, the slides that I'm going to show will be available later on. But now I think we are ready to start. So welcome to this presentation about data analytics services at CSC. And the idea with this webinar was that I will give a very sort of compact, short introduction to data analytics at CSC, maybe, well, less than half an hour, ideally. So that sort of brief overview of the activities that we have here at CSC. And moving on, so of course, the first thing to introduce is CSC itself. So I assume you all, or most of you know already roughly what CSC does. So we are a state-owned company, so kind of computing center for the state of Finland, especially for research, and located in Espoo mostly. Most of the staff is here in Espoo, but then we also have a office in Kajaani where we have all of our large computing systems. So Kajaani is both data center and also smaller CSC office. And CSC is a non-profit state organization, which means that we will primarily serve public sector and education and research, and in a very limited way also companies and private sector. And right now we are more than 400 people. And CSC's customers can be divided in 3 segments. And now that we are talking about data analytics services, so the point here is that we don't have sort of customer segment of data analytics or specific unit for data analytics, but instead actually data analytics services span all of our main customer areas. And those areas are the ones that I have here. So first, the original CSC area, research, so supporting Finnish universities of applied sciences and sector research institutes in doing their stuff, doing research, processing data, doing computation, analyzing data, and so on and so forth. And this is also the area where most of our data analytics activities are located in. And I'm personally, our data analytics group is in that area. Then we also have the services for education, which include things like student registers and collecting different data sets from education institutions on all levels, and then producing reporting and also analytics on that. So also there's data analytics activities on that area. And finally, the sort of newest, perhaps growing area is then the public sector in general. So memory organizations like libraries, museums, archives, but then also ministries and different units and organizations within the ministries, like Valtiokonttori, State Treasury as one example, major customer for us. And on that area, data analytics consultation is actually quite large activity nowadays, especially AI type of topics, discussing how AI could help different organizations and how they could better benefit from the very rich data sets that they have been collecting over perhaps for hundreds of years. So data analytics spans the whole CSC's customer base, and there's no one service for data analytics, but it's actually a collection of services and activities, and usually integrated into something else that we are doing. Then some kind of description on our customers for data analytics. So usually it is about computing and then expertise. So people and computers, that's usually the mix that we are bringing to our customers. And as you can see on the list, there's a lot of researchers, different types of researchers, and that's really how it is. So it's quite research oriented in data analytics. So of course we first have our sort of traditional research customer base. So researchers in capacity driven fields. So like the traditional supercomputing or high performance computing use cases. And nowadays these are typically cases where you combine somehow high performance computing with data analytics. So for example, use simulations to produce data and then machine learning methods to analyze them. Then we move on to sort of different types of research areas. So the sort of data-driven fields. Good examples are bioinformatics and language sciences, and well, different type of areas that use sort of geographical information. These are quite typical areas in that area sector. Especially bioinformatics is actually our largest customer group, both in numbers of users and also in the amount of computing resources that are used. And then finally, we have the sort of emerging data-driven fields, and those come especially from social sciences and humanities, and sort of areas where computing and data-driven methods have not been so common for decades, or more of a new development. And then we try to find ways to help researchers in getting their stuff done and starting to do new kinds of approaches to science and research. Then of course, in addition to researchers, we also sort of interface with research in other levels. So we are tightly knit with research IT management of Finnish universities. So for example, with Aalto University, we are actually now sort of harmonizing our computing environment so that the move from Aalto Science IT to CSC environment would be almost seamless. And then on a bigger picture, we are also in a great deal involved with research e-infrastructures. So this means basically typically European or Nordic networks of some specific field, like for example, we are working with weather forecasting on meteorological side and on sort of their community, and then on environmental sciences, ocean research and so on. Of course, also with the sort of high energy physics and with CERN and all the sort of grid computing that happens around it. So on different areas, we are part of communities, part of digital infrastructures that are required to run research on different topics. And then finally, towards sort of public sector government and then on education, so universities, high schools, vocational schools, and so on. There usually our role is more of a consultant. Of course, we also produce services and run systems in the end, but often the approach is that we start by being the consultant and finding a way to what is the data-driven solution that is required in the cases. And this is now roughly 3 boxes that summarize our most of our data analytics activities. Of course, there's, as I mentioned, data analytics is sort of tightly knitted with many of the services that we do. So it's not possible to make a comprehensive list, but this is quite close to it anyhow. So first we have the consultation box. Usually nowadays it's artificial intelligence, that's the name that is used, or then business intelligence if it's sort of a bit more traditional reporting. And our role quite often in those cases is that we sort of run some kind of pre-study projects, or even sort of just have the free-form discussions first, and then maybe define some kind of pre-study to actually understand and what the customer would need in this case. And in this case, the typical customer would be like a public sector institution, like Valtiokonttori has been one typical case in actually quite many different topics. And sometimes after the pre-study, then we move on to actually also implementing the project. So typically some kind of IT system with a lot of data collection activities around it, probably some data modeling, and then analytics and reporting in the end. But also quite often our role is not to implement, but first to do the pre-study, and then the actual implementation is sort of outsourced to private sector, and then our role is to be sort of the helping hand or the support organization for the customer. So helping in procurement and sort of also guiding the work. And of course, on the consultation area, we are also very happy to provide expertise in different forms. So maybe as a workshop or tailored courses or other sort of hire an expert type of setups. And we have data science, machine learning, and data engineering expertise, AI and business intelligence as well. So this is basically the area that we can cover, something like 20 to 40 people behind those topics, depending on how you draw the lines. And this consultation box is basically kind of normal business in that sense that it's paid directly by the customers, who often come from the public sector, sometimes also, and actually in quite many cases, we also do this kind of project on research area. And in that case, usually the funding comes from some external entity like EU or a Nordic funder or sometimes a national funding agency. But then the other 2 boxes are then more of the sort of traditional CSC basic services, and they are funded by the Ministry of Culture and Education. And this KTPO means that it's the department of the ministry that is actually funding this work. So first we have training and user support. So this is ministry funded, which means that it's freely available to researchers in universities and universities of applied sciences, and also most of the state research institutions. And the training and user support service covers courses, sort of practical courses, not university type of courses, but more of a sort of 2 or 3 days practical tool courses, like as an example, using Apache Spark for big data computing, or our practical deep learning course. These are a couple of examples. And then in addition to courses, we also provide support. So we have a service desk that you can contact and pretty much ask anything about AI or data analytics methods or tools, or technical questions about CSC's environment or tools or the software in general. And then we try to find the best expert to help you out. And then finally, we have computing services that's also funded by the ministry. Contract, of course, also can be bought as part of consultation work or just individually, but typically most of our computing services goes through the ministry contracting. So basically to researchers who don't directly pay for the service. And there we have different ways to provide computing to end users. So cloud services, high performance computing environments, then sort of higher level user interfaces, and finally sensitive data versions of the previous services, so that versions of the services like cloud environments that can be used for sensitive personal data as well. And now if we dive a bit more into our consultation box, we usually start with the customers using this kind of pyramid. So we call this steps into analytics, or analytics maturity model. And the sort of idea here is that, or this was actually invented when we sort of realized that typically customers come to us with the sort of wish that they want to have artificial intelligence, and they might have some data, and now we just have to figure out that what's missing in between. And then we created this sort of maturity model to explain that how actually artificial intelligence or any kind of data analytics is sort of high level topic, and you cannot just jump directly into it, but you actually have to take your steps and build your sort of underlying layers before you can start to have very intelligent solutions. So the first level here is collect, which means that you have to collect your data, and not only be sort of know that the data might be there, but you actually have to go and get it and have it in one place, or at least accessible. Then you need to describe your data, which means that typically the data in raw format is quite sort of hard to use. The formats are different, and you cannot directly combine or integrate data sets. So you have to describe and reformulate them. So when you have done the describe layer, you have sort of unified set of data to work with, and then you can move to actual analytics. So we call this the discover layer. So then you can start to do discoveries from your data, and also have sort of statistical thinking behind it. So you can tell the difference between noise and actual discoveries or actual signals in your dataset. And after you have done some kind of normal analytics, then you start to understand the phenomena well enough that you can actually have predictive power in your models. So you can build more advanced statistics, or you can do machine learning, or whatever is the method of choice, so that it actually can have predictive power and predict future outcomes. And then finally comes the hardest level of analytics, which is the sort of interactive analytics. And this means that the automated analytics engine is directly connected to whatever phenomenon it is sort of trying to understand. So for example, a self-driving car is directly interacting with the environment, and whatever data it receives is a result of the actions that it actually takes. So if you turn your car to left, then your view and your cameras will see different things, and this is actually very hard area, and you need years and years of work on the lower levels to actually be able to be successful here. And this whole construct is a pyramid for purpose, sort of pointing out that to have a little bit of predictive analytics, for example, you actually need to have very wide base of data, very well defined and wide data collection activities, and it must be well described and in a neat format, and you need to do your basic analytics, and only then you can sort of have production quality predictive analytics going on. Usually it's quite hard to do predictions from a single data source, but then you have to combine multiple data sources, and it means that the whole thing will spread out, and a lot of effort needs to be put to the lower levels. And the typical data sources that we work in our consultation projects are here, and especially nowadays text data is sort of important area, important topic. So of course sort of numerical data is the traditional type of data set for analytics, but nowadays people have discovered that using some sort of natural language processing techniques, you can also dig into text data sets. So typical examples are like customer feedback or customer tickets. So when you get requests from customers over the years, you will have quite a large database of requests, and also you know that what the response has been. So you can use these for analytics, and for example, machine learning type of approaches can be used here. And also another quite typical non-numerical data type are images and videos. And we've been working with some areas. So for example, in sports analytics, we've been doing some video analysis, helping out researchers to recognize the sort of body positions from videos, and analyzing if the people are training correctly or not correctly, using wrong angles, or in this case skiing in non-optimal way. And of course, in general, in research, then very major area of image-based analytics is analysis of different biological image datasets. So it's one of the biggest sources of data in the world right now. Audio is also sort of a novel area, and this is something that we haven't been working that much. And I know that in general it's not a very common area yet. Of course, sort of speech-based interfaces are a big topic right now, but still, this is sort of maybe something that will pop up later on. So we have had some small projects, for example, related to the sound of electric engines, but it has been quite limited so far. Then of course numerical data, all kinds of measurements, sensors, surveys, and so on. That's a big area. And then other technical data sources like system logs, registries, social media, sort of graph-based datasets, and so on. These are some examples that are quite typical and also have popped up in our consultation projects. And then finally about the sort of how usually these analytics projects proceed. So the first big thing is really understanding the issue. Usually people start with having some data set and what could be digged out of from the data set, and that's not the approach that we recommend, but it's more of this question that what actually needs to be fixed, because then the data that you need depends on really on the question you are trying to solve. And very often you don't have all the data you actually need, so in any case new data needs to be sort of collected, and for that there needs to be good understanding of the problem that is being solved. Then we can move on to collecting the data by ourselves or finding it for free or buying it perhaps, and then integrating and merging a lot of data, and then analysis. This is actually the easy part. When you have good question and good data set, then this is just, you need just some professional people to do the analytics at this point, and finally then reporting the results, which is actually quite demanding. Even if the problem is solved, then still implementing and making it understandable is a lot of work. I only have one example in my slides to keep it somewhat compact, but this is now example of project from a research area where we are part of a collaboration, Nordic collaboration between the numerical weather prediction offices of meteorological institutes. So this is all the Nordic countries are involved, and the idea is that could the official weather forecast be improved if we also start accepting data from consumers' weather stations. And one example is in the photo, so this NetAtmo station, it's something like 100 euros or less from Clas Ohlson. It's very common and popular in Nordic countries. And now the question is that how we could integrate this data to the official forecasting. And of course, there's a lot of issues when you start to work with consumers. So the stations are not set up correctly. They can vanish without any warning, and they can be offline for some time and then come back, and so on. The indoor station can be installed outside, or the outside station can be installed in direct sunlight, which is not how it is supposed to be done. So there's a lot of sort of different cases that you need to account. And here the things that we are working with are first of the data collecting infrastructure, but then also the sort of filtering and pre-processing. So using machine learning to identify outlier signals without actually knowing that what are all the possible issues that there could be in the consumer setups, but just identifying that this is somehow not correct signal, and then filtering them out and seeing that how it could improve, especially the sort of locality and local precision of the forecast, because the number of official weather stations is quite low. So the coverage given by these consumer stations is much more dense. Next, we move on to sort of traditional CSC activities under the ministry contract. So on the training and user support, a bit more details. So what we do, we basically have two broad topics on our courses. So one is data science, so sort of more statistical side of the area. We have data analytics with R. We are also planning to make, this is now a traditional course, but we are planning to make this into an online course as well, especially from nowadays. It's sort of very relevant idea. Then data visualization course we have been running that. It has been now on a sort of break for some time, but the idea is to get it back and make it available again. And then finally we had the big data analytics course, and our tool for that is Apache Spark. So that has been running for quite some time and has been very popular course. Then the other side of our training activities is machine learning. So we have basically two main courses, practical machine learning and practical deep learning. The machine learning is broader course, and it also covers a little bit of neural networks and deep learning topics, but it's mostly other methods of machine learning, and then deep learning sort of dives into this specific area of deep neural networks and how can you use them with text data and image data and just numerical data. Then as a special case, we have also practical machine learning for spatial data. So this is a collaboration with our spatial data specialists. So this is then basically processing geographical information using machine learning methods. And the practical machine learning course is now available as an online course, so you can just go to CSC training portal and enlist and go through the course. So there will be video lectures and then online exercises and materials. And then on user support side, we have our service desk. So when you contact service desk at csc.fi, send an email, or you can also call the service desk, but of course email is usually more effective. So it will be directed to, if it's a data analytics question, it will be directed to our experts, and then we will find the right person to help you out. And the questions vary from very abstract questions to very concrete technical questions about CSC's environment. Usually people ask when they face problems, but of course we are more than happy to help also earlier on. So sometimes we get this question that I'm planning to do my research, can you help already at this point? And the answer is that yes, we are extremely happy to help already in the planning phase, because usually you can make more impact and you can be more help early on than later on, when certain decisions have already been made and it might be hard to fix things in the analysis in the final phases. And then the most traditional CSC corner, so the computing services for data analytics. The idea is that we have a lot of computing capacity, and we try to provide it in as many ways as we humanly can. So first of all, we have cloud services. We run the container cloud, which is sort of based on the Kubernetes or OpenShift technology. So it's sort of the hype technology right now. And the idea is that the container cloud is sort of environment where you can easily launch your own, not only your own servers, but your own sort of complete infrastructure. So for example, we have ready-made templates for some dozens of different techniques, especially for the Apache Spark, which basically with a click of a button you can set up a cluster, so multiple computing nodes processing data, and then having also Jupyter Notebook user interface in front. So setting up this complex environment and also scaling it up and down as you need. If you need more resources, you can just add more nodes on the fly, and then when you don't need that much, then you can scale it down. And then we are also now going to provide Apache Kafka for streaming data. So if you need to process incoming stream of data, then you can use this to get it done quite easily. Rahti doesn't have GPU capacity at the moment for like heavy machine learning, or actually it has, but it's not public yet, so it's in internal testing right now and should be available quite soon. Then we have our Pota cloud, the traditional virtual machine-based cloud. So there you can run your own servers. So it's sort of different approach, a bit more technical in the sense that you need to manage your own servers. But Pota is, of course, quite wide and rich. So it has GPU capacity for machine learning. It has special nodes for doing sort of I/O intensive workload. So for example, if you need to run databases that are under heavy use, this is a good capacity for that. And then, well, of course, traditional capacity as well, and quite a lot of it. So it's a flexible system, but requires certain level of expertise to run. And then finally, the thing that ties everything together is the Allas object storage system. So it's basically place to put your files and access them from any of our computing environments or from your own machine. So it's publicly visible to internet and can be accessed anywhere. So this is the cloud side. Then we have the high performance computing side, which is the clusters we've been running for decades already. And right now the name of the current cluster is Puhti. It was opened like half a year ago. And Puhti has a special corner of it called Puhti AI. So it's computing nodes with GPU capacity and very fast connecting network. So with Puhti AI you can do really demanding machine learning tasks. You can connect dozens of GPUs together and do really deep learning if you need to do that. That's the sort of most powerful machine learning environment we have right now. But that's, of course, it's going to change. So we are introducing new systems. So Mahti is our sort of the big supercomputer, which is right now in internal testing and should be opened soon when it passes the testing. But Mahti is more geared towards high performance computing, so traditional number crunching areas, and not maybe so much for data analytics. Of course, there are some cases, some data analytics challenges that are suitable here as well. And especially now that we got this new LUMI supercomputer, European supercomputer, which will have immense amounts of GPU capacity, so it will be really the environment to crunch really demanding machine learning workloads. So we sort of geared Mahti, with that knowledge, we geared Mahti to be very strictly for the HPC side. So the next system to look for in the data analytics area is LUMI, and that will be available early next year. And then on software side, so we have all this capacity, but also we try to make it easily accessible, and notebooks is right now the most important service to that purpose. So the idea is that in notebooks you don't need to care about first of all, you don't need to care about CSC accounts because that's already it's quite easy. You can do it from our portal. You can get your account, but still it's quite a lot of steps. And if, for example, if you are running a course, you don't want to walk through all these steps to get the CSC account with your, say, 50 students, for example. So with notebooks, you can just log in. It supports Haka authentication, so that covers universities and also some research institutions. It also supports Virtu, which covers much of the public sector. And of course, if you have a CSC account, then you can use that as well. And if there are any other federations, like login federations that we could include, we are of course very happy to do that. So the idea is that make it very easy to get started, to log in. You don't need any installations. It works from your web browser. And then you can launch, for example, Jupyter Notebooks or RStudio Server environment. So basically kind of programming environments that are on your browser, but then they run on CSC environment and all the computing capacity comes from CSC. And in future, also, we are going to enable you to have capacity in say Rahti, and then use notebooks as a front end for your capacity, so that it's easy to get started, but you can still have large clusters running in the behind the scenes if you need to. And then finally, the sensitive data services. And right now on production, we have one service, which is ePOTA. So it's like the normal CPOTA. It's basically the same technology, but the difference is that it's better protected. So it's not connected directly to internet, and you need some special networking to access ePOTA. But after that's done, then you have a very sort of isolated and safe environment, for example, for processing medical data or some other personal data sets. And there's quite a lot of development happening on that area. So we are going to have a sensitive data archive and also sensitive data desktop services coming up in future. So that has been sort of identified as an important area for CSC, because we are sort of state-owned company. We are neutral provider of capacity, so we are in a very good place to run these sensitive data services, and this is sort of specialty that we are focusing on in future. And then finally, a bit more advertisements on the LUMI supercomputer. So the story is that EU was looking to sort of boost supercomputing and AI activities around Europe, and one way was to have this Euro HPC joint undertaking, where there are 3 different supercomputers that were open for sort of open bidding, and Finland won one of them, and the other 2 went to Italy and Spain. And it will be one of the fastest computer systems when it opens in 1 year from now. And what's important is that the way it's implemented to our Euro HPC system, so LUMI is implemented, is using a lot of GPU units. So we will have this sort of monstrous machine learning system up and running in about 1 year. And of course, we are very happy to already at this point to sort of find users for this machine learning capacity and use Puhti, our current cluster, as sort of stepping stone into then really large LUMI challenges in future. LUMI will be located in Kajaani. It will take over take over one of the paper mills there used to be in Kajaani. So Kajaani used to be a paper city, but the factory was shut down, and there are several buildings left over, and LUMI will take over one of them. Our current systems are running already on the site, but not on a paper mill building, but on a storage space. So it will be quite sizable system also physically. This was my relatively quick run through the services. I didn't manage to stay under half an hour, I see, but at least under an hour, which is good. And now let's see if we have any questions in this point. Okay, so there's question in chat. When will the ePO, the desktop service, be launched? Unfortunately, I don't know the exact answer because I'm not working with the sensitive data area. But to my understanding, it should be probably this spring, but I need to check the situation. And it will be implemented on top of ePOTA, but it's not really ePOTA sensitive desktop, but it's just sensitive desktop service. Course materials. So another question, are all of the course materials, for example, data visualization, online and freely available? The answer is that yes, I think almost all at least are online and freely available. So we have our training pages with the course archive, and the courses should have their materials available on the pages. And then we also have our new eLeena portal for online learning, but it's of course quite limited what's available right now there. So on the data analytics side, we have the practical machine learning course available freely there, but the materials of the normal classroom courses are mostly freely available. Do we have any other questions? Okay, there's a question. If we are a research team with IT capabilities and some AI, but not state-of-the-art AI capabilities, did I understand correctly we could get support from CSC on enhancing our AI solution, inclusive to the university contract? So the answer is yes. Of course, not endless amount of support, but yes. So this is something that we are happy to help. So you can contact our service desk, and well, it will come directly to our group when you send an email, and we are very happy to help with sort of suggesting what could be improved with your solution, or maybe suggesting some courses. And of course, you can start with emailing our service desk, and if needed, then we can arrange Zoom meetings or like some virtual meeting. Normally, we would be happy to also visit you at the campus, but at the moment that's not possible. But usually we can arrange meetings, either virtual or physical meetings. So yes, answer is yes. Of course, the amount of support months that we can do are limited, but at least we can get started and find ways to collaborate. Actually, quite often the end result is that we start by just using our normal ministry support funding, and then find, okay, this is a project that needs more collaboration, more work. So then we maybe apply for some other funding together, and that's also nice way to move forward with Finnish research. Then there's question, can I have the materials of practical machine learning courses, and if yes, then how? You can access them in the CSC training portal. I can send the link when I'm done with the webinar, or I can post the link also here. Yeah, actually, we could do it so that I will put these materials on the page of this webinar, and then I can also add some links to that page. So you can check the webinar page, and the links will be there. Then there's a question: is there any example of data analysis with ePOTA? How can we practice more about data analysis with the supercomputing system? Is there any tutorial about that? So with ePOTA, yes, there are examples, but unfortunately, we haven't been, our group have not been in those projects, so I didn't have any of them on the slides, but I could dig out some examples. So I will also include this information on the webinar pages. So some links on ePOTA use cases. And then if you want to know more about using supercomputing systems for data analytics, so there's and is there any tutorial about that? So yes, there are tutorials. So you can go to docs.csc.fi. There we have tutorials about the basic usage of the system. We are also writing a data analysis guide. The first version is available through docs.csc.fi. I will also add that link to the webinar page. So there's something to get you started. And then of course we have the courses. If you want to actually dive into supercomputing, then we have a lot of courses for that, of course, because that's the traditional bread and butter of CSC. For data analytics, of course, you usually don't want to really go to the supercomputing end, but more on the other large clusters that we are using. But I would recommend starting with the tutorials that we have. I will link them, and then if you need to know more, then just contact our service desk, and then we will dig out the information you need. Then there's a question: have you had any cooperation with Geological Survey of Finland, GTK, or mining industry or mineral exploration business? So the answer is that with Geological Survey of Finland, yes, we have had. They had some pilot projects for our current supercomputer project. I wasn't doing that myself, so I don't remember exactly what the end result was. But yes, we are in talks, and also they are our customers. Then with mining industry and mineral exploration business, as far as I know, there's nothing with them, and probably I would know if there would be. So quite likely no cooperation on that direction. Okay. Now it seems that there's no more questions, I guess. So could you provide more use case examples about the use of CSC computing services? Yes, we can do that. And there's actually the sort of tutorials that we've written are written in with the idea of sort of from the point of view of use cases. So that's maybe the first thing to look at. Then if you want to know more in more detail that what kind of challenges have been on sort of from high level, then you can of course check out the CSC news. So we provide news articles about different research projects, like for example there's one about prostate cancer quite recently, and of course now one case about coronavirus spread. So there are these sort of high level descriptions available. If you are looking into sort of very concrete example that how this was done, then that's something that's not available right now. It has been discussed that maybe we also should have this sort of actual practical cases and very detailed descriptions on how they were done. So we do have some webinars describing some cases, but but not any written material on that area. So I would start with the tutorials we have, and then if you need more examples, then just contact us and we can try to find more. Okay, now it seems that we are probably done with questions if there are no more. And yes, so the recording will be available on YouTube. I will add links for more information to this webinar page, and I will also add my slides there. And well, if you want to ask something, here's my email, aleksi.kallio@cscfi, or if you just contact CSC service desk, that will also, the mail will find it a way to right person. That can be used as well. Happy to help with any questions or any challenges that you might face with data analytics. And finally, on chat you can see the link to our feedback form. So we'll be very happy if you can go there and give your feedback about this webinar, and also suggest some future topics for future webinars, so we can then cover important areas in future, especially now that webinars are the way to go for the time being. So of course very happy to hold these. But it seems that we are done now. So thank you very much for attending. I hope this was a useful hour about our services, and get in touch if you want to know more, or if you're having troubles with using some service or some system, or need some suggestions, then just fire or email and we can try to find a way to go forward. Thank you.